Hello everyone, I am Harshita.
I'm Shruti. I am Anjali. We are going to give a brief note on the topics PVM, that is Python Virtual Machine, installation of Python in Windows, and pip command.
Python Virtual Machine. The Python Virtual Machine is the runtime environment in which Python programs are executed. It is responsible for interpreting and executing Python bytecode, which is the intermediate code generated from Python source code or compiled modules. When you run a Python program, the source code is first compiled into bytecode. The bytecode is then executed by the PVM machine, which acts as an interpreter. The PVM includes various components such as bytecode interpreter, memory manager, and support for dynamic loading of modules. We know that computers understand only machine code that comprises ones and zeros. Since computer understands only machine code, it is imperative that we should convert any program into machine code before it is submitted to the computer for execution. For this process, we should take the help of compiler. A compiler normally converts the program source code into machine code. A Python compiler does the same task but in a slightly different manner. Takes the program source code into another code called bytecode. Each Python program statement is converted into a group of bytecode instructions. Then, what is a bytecode? Bytecode represents the fixed set of instructions created by Python developers, representing all types of operations. The size of each bytecode instruction is 1 byte or 8 bits, and hence these are called bytecode instructions. Python organization says that there may be newer instructions added to the existing bytecode instructions from time to time. We can find bytecode instructions in .py file. Following figure of role of virtual machine in converting bytecode instructions into machine code. The role of Python virtual machine is to convert the bytecode instructions into machine code so that the computer can execute those machine code instructions and display the final output. To carry out this conversion, PVM is equipped with the interpreter. The interpreter converts the bytecode into machine code and sends that machine code to the computer processor for execution. Since interpreter is playing the main role, often the Python virtual machine is also called as interpreter. And now memory management. Everything is considered as an object in Python. For examples, strings are objects, lists are objects, functions are objects, even modules are also objects. For every object, memory should be allocated. Memory manager inside the PVM machine allocates memory required for objects created in a Python program. All these objects are stored on a separate memory called heap. Heap is a memory which is allocated during runtime. The size of the heap memory depends on the random access memory of our computer, and it can increase or decrease the size depending on the requirement of the program. In C or C++, the programmer should allocate and deallocate memory dynamically during runtime. For example, to allocate memory, the programmer may use malloc function, and to deallocate the memory, he may use free function. But in Python, memory allocation and deallocation are done during the runtime automatically. The programmer need not to allocate memory while creating objects or deallocate memory when deleting the objects. We know that the actual memory RAM for any program is allocated by the underlying operating system. On the top of the operating system, a raw memory allocator oversees whether enough memory is available to it for storing objects. On the top of the raw memory allocator, there are some object-specific allocators operate on the same heap. These memory allocators will implement different types of memory management policies depending on the type of the objects. For example, an integer number should be stored in memory in one way and string should be stored in different way. Similarly, when we deal with tuples and dictionaries, then they should be stored differently. These issues are taken care by object-specific memory allocators. And now coming to the Python virtual machine flowchart, here the code written by us is known as source code, and this source code is converted into bytecode using the compiler. Here compiler means Python interpreter, that means PVM machine. And now this Generated bytecode is converted into machine code using the PVM machine. The format or produced machine code is the output for this process.
Installation of Python in Windows. Python is a widely used high-level programming language. To write and execute code in Python, we first need to install Python on our system. Installing Python on Windows takes a series of few easy steps. Step 1. Select version of Python to install. Python has various versions available with differences between the syntax and working of different versions of the language. We need to choose the version which we want to use or need. There are different versions of Python 2 and Python 3 are available. Step 2. Download Python executable installer. On the web browser, in the official site of Python, move to the download for Windows section. All the available versions of Python will be listed. Select the version required by you and click on download. Let's suppose we choose the Python 3.9.1 version. On clicking download, various available executable installers shall be visible with different operating system specifications. On clicking download, various available executable installers shall be visible with different operating system specifications. Choose the installer which suits your system operating system and download the installer. Let's suppose we select the Windows installer 64 bits. The download size is less than 30 MB. Executable. Step 3. Run executable installer. We downloaded the Python 3.9.1 Windows 64-bit installer. Run the installer. Make sure to select both the checkboxes at the bottom and then click Install New. On clicking the Install Now, the installation process starts. The installation process will take few minutes to complete, and once the installation is successful, the following screen is displayed. Step 4. Verify Python is installed on Windows. To ensure if Python is successfully installed on your system, follow the given steps. Open the command prompt.
Now coming to the pip command. The pip command looks for the package in PYPI, resolves its dependencies and installs everything in your current Python environment to ensure that request will work. The pip install package command always look for the latest version of the package and installs it. Pip is a package manager for Python. It is used to install, manage, and uninstall Python packages, which are pre-built libraries or modules that provide additional functionality to Python programs. Here are some common commands and usages of pip. Install a package. To install a package from the Python package index, you can use the pip install command followed by the package name. For example, pip install request install the request package, which is commonly used for HTTP request in Python. Install a specific version of a package. You can install a specific version of a package by specifying the version number after the package name. For example, pip install request 2.26.0 installs version 2.26.0 of the request package. Install packages from a requirements file. A requirements file lists all the packages required for a project. You can use the pip install R command followed by the path to the requirements file to install all the packages listed in the file. For example, pip install R requirements.txt install the packages specified in the requirements.txt file. Upgrade a package. To upgrade a package to the latest version, you can use the pip install upgrade command followed by the package name. For example, Pip install upgrade request upgrades the request package to the latest version. Uninstall a package. To remove a package from your system, you can use the pip uninstall command followed by the package name. For example, pip uninstall request uninstalls the request package. List installed packages. You can view a list of installed packages by running the pip list command. This command displays all the packages installed in your Python environment along with their versions. Search for a packages. If you want to search for packages available on PyPI, you can use the pip search command followed by the package name or keyword. For example, pip search numpy displays a list of packages related to numpy. The commands correctly installs the request package with pip is pip3 install requests. The commands will show you package details for a single package that has been installed with pip is pip3 show package name. The pitfalls associated with using third-party packages in a project is there are no pitfalls associated with third-party packages. Install them all. Okay, what is pip in Python with example? Pip is developed in 2008. Pip is today the standard tool for installing Python packages and their dependencies in a secure manner. Most recent distributions of Python come with pip pre-installed. Python 2.7.9 and Python 3.4 and later versions include pip by default. Basic pip commands are pip install, pip list, pip install package name.